Okay, so a biologist is interested in studying the effect of growth-enhancing nutrients and different salinity, or how much salt is in water, on the growth of shrimps. The biologist has ordered a large shrimp shipment of young tiger shrimps from a supply house for use in the study. The experiment is to be conducted in a lab where 10 tiger shrimps are placed randomly into each of 12 similar tanks in a controlled environment. The biologist is planning to use 3 different growth enhancing nutrients, A, B, and C, and 2 different salinity levels, low and high. Now, list the treatments that the biologist plans to use in this experiment, and then using the treatments in part A, describe a completely randomized design that will allow a biologist to compare the shrimp's growth after 3 weeks. So we'll do A and B on the next slide. So first I see that there are 6 treatments. You have nutrient A, high and low salinity, nutrient B, high and low salinity, and nutrient C, high and low salinity. These represent the treatments, and that is A, done. So since I have 12 tanks, one treatment will go into 2 different tanks. So I randomly assign numbers 1 to 12 to the 12 tanks. 1 and 2 get nutrient A, low salinity. 3 and 4 get nutrient A, high salinity. 5 and 6 get nutrient B, low salinity. Continues, and this process continues until 11 and 12 get nutrient C, high salinity. So all of our treatments are basically assigned to the random numbers. One of the things I might do to clarify this is I would say, see this numbers, and I would say 1 and 2, 3 and 4, 5 and 6, and then random number like that, and 7, 8, 9, 10, 11, 12. I think you get the idea. But I think this answer would probably be enough because I've explained fairly clearly what constitutes random assignment. Now we've got C and D. Give one statistical advantage to having only tiger shrimps in this experiment, and why this is an advantage. First, we have reduced variability. We've reduced variability by not putting other shrimp species in the experiment. So reduce variability by not putting other shrimp species in the experiment. Now we can look at growth factors such as a function of our treatment levels and not worry about all these other variables that might be involved of other species. Now, one statistical disadvantage of having only tiger shrimps in this experiment is that I can only apply the results of this experiment to tiger shrimp, to the population of specifically that type of shrimp. Okay, I'll write this. So we can only apply the results of this experiment to these types of shrimp, not other types of shrimp, because we have no basis of comparison. And we haven't done any experiment on other types of shrimp, so how can we make inference on the population of other types of shrimp if we haven't done anything with other types of shrimp? So it can only apply to tiger shrimp populations. And that's it. Have a nice day.